Well, hello everyone. Welcome to MGF 1106 online. I hope this is a temporary thing, but either way, we'll get through just fine. I will be uploading these lectures to my YouTube channel and then putting links to them up on my courses. So hopefully you'll find that process very easy to navigate and you'll have no problem accessing the videos. So let's jump right in. So we're picking up at the section 11.6 on conditional probability. At this point, I need to remind you to try to look for distinguishing characteristics of the different probabilities. Last week we studied independent and dependent, and mutually exclusive and non-mutually exclusive. And tonight, 11.6 is conditional, and there's still a couple more. So please start to look for distinguishing features in the problems as you're doing the homework. Notice how the problems are similar and how they're different from last week's. All right, that'll be very, very helpful. You might even want to take some notes on the distinguishing characteristics. Okay? All right. Well, conditional is actually one of the easiest of the ones that we'll cover. Basically, it just involves two events where we're trying to find the probability of the second event given that the first event has already occurred. Kind of like a conditional, right, from chapter 3, kind of if, then, if this happens, then that'll happen. So the notation for this is this right down here. Probability of B given A. And that's what the bar means. The bar means given that. So we know something's happened, then find the probability of the second event. So it's basically more information than you normally have in a problem. Okay? It's similar to dependent probability, but you have more information. And it's really somewhat obvious when you have these problems, because it actually uses the word given that. It'll actually say that in the problem, given that. The book has a formula, what else is new, that I don't think you need, but we'll mention it. Okay? All right, so here's an example. A single card is selected from a deck of cards. Determine the probability that it is a club given that it is a black card. Well, again, the given that is something that basically changes the problem. You have less cards to deal with because it's black. Okay, that means we're only dealing with 26 cards, right? Not dealing with the whole deck, like some of the people you know, right? Sorry, the jokes keep coming. So you have. I took a card from a deck, and I said, okay, you got to guess the card, but I'm telling you, I'm giving you a hint. It's a black card, all right? Well, now that you know that information, okay, how many clubs are there? Well, there's 13, right? So this problem would look like this. Probability that I drew a club given that it's a black card. So right away, the bottom, instead of being 52, it's 26. The condition changes information about the problem. In this case, it changes the number of cards that are even in play. Okay? So now, how many clubs are there? Well, 13. So instead of it being a 1 out of 4 probability from an entire deck, it's a 1 out of 2. It's a 50-50 proposition that you're going to draw a club given that the card was selected was a black card, because there's only 26 black cards and the clubs are 13 of them. Okay? So like I said, pretty straightforward. You get to use your intuition and your common sense, and I think on the next slide you're going to see the formula, which I think is way too much information. Or no, maybe not. I know there's a formula coming up. We'll get there. All right. So here's another situation. Suppose your professor goes stark raving mad. Hold your comments to yourself. And chooses your final grade A, B, C, D, O, F, or incomplete, totally at random. Okay, I don't think you would like that proposition too much. Find the probability of getting an A given that you got a letter grade higher than a D. In other words, you go in to see your professor and you said, hey, what grade am I gonna get in this class, since I've heard you decide on grades totally at random. Okay, I know, crazy scenario. So you're talking to the professor and he says, well, let me give you a hint. You got a grade higher than a D. Well, that's your condition, okay? So you're looking for the probability that you got an A given that your grade is greater than a D. Well, how many grades are higher than a D? How many total? 3, right, A, B, or C. So there's only 3 possibilities as opposed to 6. There were 6, A, B, C, D, F are incomplete. Now there's only 3. And how many A's are in that group? Well, there's only 1 grade of an A possible, so you have a 1 out of 3 chance. Okay? All right. Oh, okay. Here is how the book would have you work this out. Okay, the formula is on page 683, and the sample space is all the possible grades. They've assigned an I as the incomplete. So there's your 6 grades, and the book would say, hey, what's the probability of getting an A given that your grade is higher than a D? So they lay out the information. The probability of A is 1 out of 6. Probability of letter grade higher than a D is 3 out of 6. And then they do the computation of those divided by each other, and you get the answer of 1 out of 3. Now, I don't know about you, that is a lot of unintuitive work that I would just as soon see you avoid. You all are way too smart to need to lean on a formula that confusing. Okay? All right. All right, so let's just kind of keep practicing. This is a pretty short lecture. It's only over one idea, conditional probability. Again, keep looking at the problems. What is tipping you off that it's one of these conditional probabilities? Sometimes you'll see these problems show up in survey information or where there's a lot of data involved. So we've got 250 patients who had knee, hip, or heart surgery, and they were asked whether they were satisfied, dissatisfied, or neutral regarding the results of their surgery. The responses are given in a table on the next slide. Okay, well, this is kind of customer service type follow-up information, so this is pretty realistic. Okay, so here you go. Take a second and kind of orientate yourself to the table. Notice how you've got things running horizontally. In other words, the knee, all the data from the knee surgeries are running this way, right? Satisfied, dissatisfied, total. And then you've got your satisfied. All the satisfied results are running vertically, dissatisfied vertically, and total numbers are vertically. So just be careful when you pull numbers from the table, okay? All right, so one person is selected from the patients surveyed. If one person from the 250 patients surveyed is selected at random, determine the probability that the person was satisfied with the results of the survey. Okay, so you're just picking one person, okay, and you're wondering what's the probability again, so we have a ratio, right? Probability that the person was satisfied with the surgery. All right. So this is not a conditional probability. This is just asking you the likelihood that they were satisfied. Okay, well, how many satisfied people are there? Total of what? How many? 210, right? Okay, and the total number of people that had surgeries? 250. Okay, so the probability that the person was satisfied is just a basic probability problem, okay, just a basic. It's going to be 210 out of how many? 250, okay? That's really not a conditional situation. That was just a basic probability involving how many satisfied out of the total, which is, I guess, pretty good numbers. If you were looking to, do a review or read reviews about a doctor, right? You're going to look at the number of people that were satisfied. Okay? All right. And you can see this is not a conditional probability situation. All right, now B. Find the probability that the person was satisfied with the results given that the person had knee surgery. Okay, there's a condition. There's a condition. So the formal notation for this would be probability that they were satisfied given that, that's what that bar is, given that they had knee surgery. Okay, well remember, all the condition does is adjusts the total. So we're not dealing with all 250 people this time. How many people had knee surgeries? 95, right? 95. Now, this is where it's a little tricky because we're still looking at satisfied, but we're not concerned about all the people that were satisfied because we've already limited it. We're just talking about those that had knee surgery. So now you're only looking at this row. Okay? And of the people that had knee surgery, 95, how many of them were satisfied? 75. Okay? So over 20% were not satisfied. I don't know if that's a good number for me, but that's how you do that problem. Okay? All right. Here's another one. Find the probability that someone was dissatisfied, all right, dissatisfied with the results, given that the person had hip surgery. Okay? Go ahead and pause the video, okay? Pause the video and work this problem out, and then start it back up again and see how you did. I'll wait. All right, let's see how you did. So, given that, so let's see, probability that the person was dissatisfied given that they had hip surgery. All right, well, hopefully you realize that the given that, the condition, changes the total. In other words, now which total we want? Hip surgery. So here's hip. Here's all the numbers involving hip surgery. All right. There were 105 that had hip surgery. How many of them were dissatisfied? Well, look up and 15. So whatever that percentage, it's about 14% or so, like 0.14 or something like that. Okay? Hopefully you got that one correct, and you're starting to see that the conditional probability is actually one of the easiest ones because of the given that and the fact that it tells you right there what kind of probability it is. Okay? All right. Here's another one. I'm going to give you a chance to pause the video and go ahead and work it out, and then start the video back up, and we'll see if you got it. And I'll just wait. Okay, so you're back. So let's see, had heart surgery. All right, heart surgery. Oh, find the probability that they had heart surgery given that the person was dissatisfied. Ooh, they turned it around on us. Okay, so find the probability that you're going to select somebody that had heart surgery given that they were dissatisfied. All right, this one's cool. So hopefully you said, oh, given that, that's my total. So given that, dissatisfied. Well, here's my dissatisfied group. And there's a total of 40 of them. Okay? Now, of those dissatisfied people, all right, and here they are. Here they are right here. Okay? How many of them had heart surgery? Well, just look for the intersection between heart and dissatisfied, and I hope you got those 5 right there. 1 out of 8 or 5 out of 40. If you got that, good job. I wish I could see you. I miss you guys already. I don't like this, but we'll make the best of it. Okay. And we're done. All right. So what we'll do is, after you have tried the homework, all right, if you have questions, email me which ones, and we'll figure out the best way to proceed from that. I'm hoping that you guys continue to do a great job and don't have a lot of questions, but we'll keep in touch. Okay, I'm going to upload this video now and move on to the next one. All right, take care. Bye-bye.